Hi, this is Gal Somerville, and I'm talking to you here from ARI when I'm just finishing up my PhD. Now, this is some visuals to help explain some of the concepts in my first paper, which was looking at why pre-emergence herbicides have lasted a lot longer than post-emergence herbicides. So this is the first picture, and what we've got here is the growing season, obviously from the end of the summer through the beginning of the next summer, and we've got the ryegrass coming through, and we've got this gradual sequential emergence of the ryegrass right through the season. So at the start of the season, we've got the weeds that come up here before the crop is sown, and we've called them cohort 1, and they'll be killed with that pre-setting knockdown herbicide. And then if we go on, we put the pre-emergence on, its crop seeding, and then until that's finished working here, those weeds are all in cohort 2, so all the weeds that are affected by the pre-emergence herbicide. And then the later germinating weeds that are still coming up until the post-emergence is applied, and then those weeds are in cohort 3. So the weeds in cohort 2 end up affected by the pre-emergence herbicide, and then the weeds in cohorts 2 and 3 are both controlled by the post-emergence herbicide, because it's controlling all those weeds that have survived the pre-emergence herbicide as well. So you can see that anything that survives the pre-emergence will be controlled by the post-emergence, and also all weeds that are resistant to the post-emergence in cohort 2 could be controlled by the pre-emergence, but the weeds in cohort 3 that are resistant to the post-emergence herbicide have no control. So that's something we might get with trifluralin if that was our shorter acting pre-emergence herbicide, followed by something like clethodim. Whereas if we used a longer acting pre-emergence herbicide like propyzamide, then that cohort 2 becomes much longer until the pre-emergence stops working, and then we've only got very few weeds that are only controlled by a single herbicide. So everything that's resistant to the pre-emergence herbicide is going to be protected by this post-emergence application later. But anything that's resistant to the post-emergence in cohort 3, there's still no control, but we've got the numbers of them right down as low as we possibly can. So firstly, looking at that shorter pre-emergence herbicide, and if we look at the results from that. So this is the way I've presented my results, and it's actually a spatial model. If you've got really good vision there, you should be able to see those tiny little white outlines on the squares. So each one of those is a little subpopulation that we generated separately, so we can look at the flow of genetic material across the field. And you can see the vertical lines. Well, that's the harvester trails, because the harvester's picking up this genetic material and spreading it. So, and because it's what we call a stochastic simulation, you get variation in each one. This will just be one of the average results. So the light yellow colour is a very low number of weeds. If we look over here, you can see that's a very low concentration of weeds, whereas anything above 25 weeds per square metre is the black colour. So what we can do also with this spatial modelling is we can look at the genetics of those weeds. So that's what I brought up on the next slide. So we've split those weeds that are in that initial field up into susceptible pre-emergence resistance, weeds containing the post-emergence resistance, and then any weeds containing resistance to both those herbicides. And you can see that the vast majority of those weeds in this field with the shorter acting pre-emergence herbicide have developed that post-emergent resistance by year 9. The numbers have got quite large. And we've also unfortunately got a little bit of multiple resistance coming through as well, just because that post-emergence was existing in the field for several years, and then the pre-emergence resistance can sort of piggyback on that and start to build up in the field as well. In contrast, if we look at the one with a longer pre-emergence herbicide like propyzamide, then it's giving a lot more protection to the post-emergence herbicide. And if we look at the results from that, so in this simulation, there's only resistance we're getting is the multiple resistance in this simulation. I mean, that's a lot rarer, obviously, and in some simulations you don't get any of that. And here, even the post-emergent resistance is all kept under control, because we've had a very good pre-emergence herbicide in the simulations. So hopefully that goes some way to help you understand why pre-emergence herbicides have lasted a lot longer, because they've always had this protection by the later applied post-emergence herbicide that kills all those resistant weeds. And if we need to, extend that to protecting our post-emergence herbicides as well, then we need to have a double knock on these later emerging weeds. Okay, thank you.